For the last couple of class periods, we've been talking about ecological succession and the different models of succession that apply on rangelands or might potentially apply on rangelands. And we talked about the first and earliest one that was a concept coined by Frederick Clemens actually 100 years ago this year in a book that he published, and he referred to it as simply succession. And people later on called it Clemensian succession, and then when we started coming up with different examples of how plant succession might work, people referred to it as relay floristics, or the facilitation model of succession. And so for relay floristics, basically we have one plant community after disturbance. Say you have an old field that's been abandoned, and it's not hard to imagine that it gets occupied by a lot of weedy annual plants or those pioneer species that occupy that site. And then we have a relay. What those pioneers do is they modify the site, make it more suitable for the next suite of organisms, which we'll just call seral stage 1. Then the next suite of organisms that's relayed in is seral stage 2, and then ultimately we reach a climax plant community. And a lot of times that really didn't happen on rangeland situations. It seemed to stall out. But what I thought we would do out in the field today is just go out to a gravelly range site or ecological site and look at it, just do a little overview of that site, and then run a relay race in teams to kind of bring home the concept of that relay floristics. And so I think we have about 16 of us in here today. We're a few short, but what we're going to do is divide up into teams and get you set up for that. But we'll do the relay floristics, and then we're going to do the state transition model. But I want to set the stage for succession. So what we're going to do too is just have you go through a process where each of your teams will be a green state, which is the short and midgrass shrub complex. That's the good state. And then it's a bit alarming. So yellow, we move transition 1. That's that rapid transition that usually occurs to a new stable state, which is red. It's the less desirable state, and that's the shrub and shortgrass complex. And then if we can implement good management over a decade or so, we might move back to the former state through this transition back to the green state. So just to help lock these things into your mind and help you think about what's going on out there, I hope that by going out in the field and doing a couple of these just really simple and silly exercises, we can reinforce those concepts. Okay. So the number 1 team leader, raise your hand. Number 2 team leader, 3 and 4 of those are your team leaders. Let's assemble and just walk across the street. It hasn't worked out that way. But what I thought we'd do is, in your teams, so let's just do team 1, team 2, team 4 with your baton, and then let's go about 25 paces for our relay. So the rest of the team come with me. So when you guys come down the first leg of the relay, when you relay to your next person, you go seral 1, okay? Because you're relaying to the first seral stage. Everybody with me? Seral 1. Okay, so the second leg of the relay, that person stay here, and the next couple come with me. Here's the next one. So seral 2 comes down to the next stage, What's this stage going to be, the final stage? Climax. Okay? So are our starters ready?
What? Oh, we're actually like going.
You expect me to run.
Go.
Hey, Cyril,
Come on, T4!
Cyril 2.
Run like you never run before! Yeah!
Okay, put up. Yeah, I'm with Mark.
Yeah, here.
Alright, hold on. Four.
Yeah, it helps, Mark.
Close your eyes, it helps.
Okay. All right, so let's come back down around here. Cyril 1 coming out of you, then to Cyril 2, and then down to the climax. And did you see what I made the climax community do? They're in a state of dynamic equilibrium. They vary from year to year, but they should stay that way somewhat indefinitely until some disturbance or something pushes them out of that configuration and back through some successional sequence. So that's why they went in circles. What we're going to have is each team has these cards, so the team leader can choose who's going to be state 1, the green card, and then you can hand that yellow transition 1, T1, to a second team member, and then the state 2 to a third member, and to your fourth member, and the transition, that R1 transition. And if you have more than 4 members, 2 of you just double up someplace. Transitioning. And so you hold your green card up. Hold your green cards up. Okay, the yellow transition, you hold the card up and move your group to your shrub cluster that you've picked, okay? All right.
Wait, yellows go to shrub?
Yeah, yellows are the transition 1A.
Yeah.
So, all right. So hold, red cards hold up. So that's state 2. So we went from state 1, more of an open grassland, to state 2, more of a enclosed shrubland. And then say we come into this area and we manage it. We do some brush management. We come in and treat these shrubs, and we remove grazing for a number of years. And if we put grazing back on these sites, we do it at a much lower stalking rate. And hopefully we have some favorable weather and some good things happening. And now, where's your tan cards? Tan card members, under favorable management, we can maybe get back to this more open grassland site. So your tan card transition folks, you go back to your green card folks. Okay? So basically, in theory, if the ecologists have the models down right for this particular gravelly site, you just bounce back and forth between these 2 states through time, depending on what management and environmental conditions are going on. It's a very simple system, but we don't have a lot of other complex things going on. But what can throw that all into a kink? So come on over around again. Ideally, we would be able, through management, to get back to where we were under historical conditions. What kinds of things do you think might happen that might throw that off?
Overgrazing?
Yeah. Overgrazing, and not so much necessarily overgrazing, but what are some of the net results of overgrazing?
Erosion?
Erosion, and what happens when you have severe erosion? That's exactly right.
Soil runoff?
You lose your soils, and do you think soils out here form quickly or slowly?
Very slowly.
Very slowly, because we're a very arid environment, and they're very shallow, very variable soils. So if we lose a lot of soil to erosion, you think the site potential is the same as it was to start with?
Yes.
No, you did grade this side. But do you feel now that you've got a little bit, now that we've done this sort of silly exercise, does it help make it register a little bit more what's going on with those successional processes? I know that a lot of times I talk about this in class, I give illustrations, but it never really resonates with the class. So Dr. Warnock and I have been talking for a number of years of ways that we might be able to try to bring this thing home. And sometimes when you get out and you just do something, it illustrates it a little bit more strongly. So.
Well, my major is conservation biology. I'm hoping to work with tribal lands to restore fisheries. My bachelor's degree is in Native American Studies, so I'm hoping to combine my education here at Sul Ross with New Mexico State University.
I'm majoring in conservation biology. What I hope to do is use drones in order to help determine populations for an area, different species, endangered species. And this helps a lot with actually being able to see the succession instead of just reviewing it in the book, and actually being able to come out and see what this land can actually hold.
I think that a process like this gives you a better idea, a better understanding of succession through doing exercises like the one we did today.